This video will just continue where the previous video left off. We're still looking at graphs of trig functions and trying to figure out algebraically some properties that they might contain. And we're going to connect it back to some algebra ideas that we've been using for a number of years. So in this case, we're looking at where would x squared plus 10x equal the graph of negative 21, which is just a horizontal line. And to solve that algebraically, you can kind of get a sense of what the answers are going to be numerically just by looking at those 2 points right there, the x values of those 2 points. But to solve that algebraically, I literally would just put the two things together. I'd say, where does x squared plus 10x equal negative 21? And to solve an equation like this, I'm going to think about going x squared plus 10, and I just noticed I should be putting an x right there. I'm going to bring that 21 to the other side. So I'm going to have a plus 21, and all of that now would equal 0. So we're going to be factoring. We're going to be, in some ways, unfoiling, if that idea makes sense to you. I want to think about two numbers that would multiply to 21, but add to 10. Those two numbers would be, doesn't really matter the order in this case, but 3 and 7. And then I go back to some of the things we discussed in previous videos. I have two chunks here, x plus 3 and x plus 7, and it equals, when I multiply them, it equals 0. So either this has to equal 0 or this does. You will be able to do this in shorter amounts of writing down the road, but I'm going to write it out pretty thoroughly here. Either x plus 3 equals 0 or x plus 7 has to equal 0. So that means x could equal negative 3 or x could equal negative 7. Okay, that's a pretty standard question from a previous course. Let's see how that would relate to something in our current study of trig. I need to erase all this. There we go. Okay, where would sine of x being squared plus 2 times sine of x, where would that equal negative 1? So again, we're going to be graphing two functions. I don't expect you to know what this top function looks like. I do expect you to know what y equals negative 1 looks like, pretty easy. But you see that they do touch every so often on a fairly regular basis. So how could I just have this, the equations, how could I work backwards and figure out where they actually intersect? So same sort of idea. I want to actually write this out and say, where would sine of x squared plus 2 times sine of x, where would that idea equal negative 1? And we're going to do the same thing we did previously. I'm going to make one side equal 0. So if I bring that negative 1 over, I really have a plus 1, and now it's going to equal 0. Okay. So now I get into this idea of unfoiling it. So just think of sine of x as just being like x or y or some other variable. Really, I have x squared plus 2x plus 1 equals 0. It's the same basic idea. If that does not make sense, right now you need to jot down a question so that we remember to talk through that a little bit more in class. But it's the same sort of idea. I'm going to look for two numbers that multiply to 1 and add up to 2. Obviously those numbers are, give you a minute to think about that, but those numbers would have to be 1 and 1. So I end up with the idea of, and I'll go down below the graphs here, I have sine of x plus 1 times sine of x plus another 1 equaling 0. If I were to actually FOIL those pieces together, I get sine squared plus 2 sine of x plus 1, all equaling 0. So because these two things are exactly the same, I really only have to solve it once. Either this part equals 0 or this part equals 0, but because they're exactly the same, I'm solving the exact same thing. I just want to know where this is true. So really I want to know, where does sine of x equal negative 1? And if you think through your unit circle, where are the y values equal to negative 1? In radians, that's at the very bottom of the unit circle. That means an angle measure of 3 pi over 2. Okay, moving on to our last algebra type example. Again, let me erase this really quick. There we go. This is another x-intercept sort of thing. Where does 5x squared plus 23x plus 12, where would that function have an x-intercept? Excuse me. So to answer that, we need to think, where does this function equal 0? And so now it gets into a little bit more of a complex idea. We need to really think through, what would I have done in Algebra 1 or Algebra 2 to solve this? I'm not saying that this is the only way that you could have learned this. This is just the way I know some courses have taught it. You would kind of label the numbers in the equation as A, B, and C. And what you want to think through is, what does A times C equal? A times C, in this case 5 times 12 is 60. And then the way I like to do this, I say B is 23. I want to think about two numbers that would multiply to 60 and add up to 23. So you need to try a few things. There's not going to be an easy answer for this, but you do want to try, just start thinking through some ideas. So what are some options here? Well, I could think through 2 and 30. Okay, and that's not going to work because the sum of that is 32. So I know that's not going to be what I want. I could think through 3 and 20, and lo and behold, I get 23. Okay, so I'm going to use 3 and 20. And the way I'm going to use those numbers is I'm going to use them to rewrite the middle term. So I'm still going to have a 5x squared, and it doesn't really matter the order that I put this in, but just because I did 3 and 20 on the previous one, I'll write it as 3x plus 23x. I'm sorry, let me undo that. Undo, there we go. Oops, a little too much there, but plus. It'd be a 20x, right? My numbers are 3 and 20. So 5x squared plus 3x plus 20x plus the original 12 still has to equal 0. When I do that, I have not changed the middle term really. It's still 3x plus 20x. It's still 23x's. I've just split them up. But now I should be able to look at these two parts. Kind of doing the process of chunking. I'm going to look at these two parts and these two parts and factor them separately. So what do 5x squared and 3x have in common? They have an x in common. And I'd be left with a 5x plus 3. Okay, so in there, go. Okay, I just dealt with this part to get this. Then I do the same thing here. What do these two things have in common? 20x and 12, they have a 4 in common. And I'd be left with a 5x plus a 3. If I'm doing this process correctly, I should see two 5x's plus 3's occur, or the same things appear in the parentheses. That means I'm doing it right. Okay, so now I want to deal with this whole chunk at once. What I'm going to do is realize they do have something in common. They have 5x plus 3 in common. It is large and it's a little bit more complicated, but it's really no different than just saying they have a y in common or a z in common. I can still pull that out to the front, and I see what each part has left. I have an x left and a 4 left, and that's going to equal 0. Okay, let me get rid of this thing a second. There we go. So now we have our two parts multiplied together equaling 0. So either 5x plus 3 has to equal 0, or x plus 4 has to equal 0. This one's a little easier. X would equal negative 4. Or if I took the first equation there and solved that, I get 5x equals negative 3, or x equals negative 3 over 5, which is really negative 0.6. Okay, if you go back to your graph, that does look to be like our x-intercepts. So my point here, that was a lot of review, but that things can get a little bit more complicated. If you can relate it back to a basic algebra problem, you'll be in pretty good shape. In this case, we had to think through a fairly complicated system of unfoiling. Okay, one more example here dealing with trig. Get my mouse back there. Okay, So where would the function 2 times sine of x squared plus sine of x minus 1, basically I'm asking in this case where are the x-intercepts. So where does this thing equal 0? Okay, this is more complicated. I do need to explain the notation up here. This is just the way that Sketchpad types this in. This is really just 2 sine of x squared plus sine of x minus 1. So I'll probably rewrite it here at some point. But we want to go through the same thing. I want to think about a times c, and that would be negative 2. And I want to think through my b value, which is a positive 1, right? The coefficient in front of this middle term. Sine of x is our variable here. So my coefficient of sine of x here is positive 1. So what are two numbers that would multiply to negative 2 but add up to positive 1? And that would have to be a positive 2 and a negative 1. That's the only way that that can happen. Okay, so now I'm going to rewrite that middle term using 2 and 1. Right, that equals 1 there. Okay, so I would have, over here, I'd have 2 times sine of x being squared. One thing for this, as I rewrite my middle term, I often put the negative 1 first. If there's ever a combination of positive and negative, I put the negative 1 first. So a negative sine of x, negative 1 sine of x if you want to put it that way, plus 2 sine of x. And then the number at the end, the c value, was a minus 1. All of that would equal 0. Okay, so we chunk again. Let me get a different color here. Think about what do these two parts have in common, what do those two parts have in common, and go from there. Okay, the first two parts, or the first chunk, a little bit easier. They have a sine of x in common. And I'd be left with, in the first part, a 2 sine of x, and the second part, a minus 1 now, right? It's all taken away, so a minus 1. In the first part, I really have nothing that's in common, so I just have to put a 1, and I have a 2 sine of x, minus 1 left behind, which still equals 0. And so you see that in this, same chunk here, same chunk here. And I realize I'm going to have to hustle here because I'm running out of time in the space I can film. So what do they both have in common? They both have a 2 sine of x minus 1 in common. I pull that out to the front. The first chunk has a sine of x that's left. The second chunk has a plus 1 that's left. Equals 0. Okay, and I go from there. In this part, if this were to equal 0, so if 2 sine of x minus 1 equals 0, if I were to solve that, I get 2 sine of x equals positive 1. So sine of x would have to equal 1/2. So where would sine of x equal 1/2? Where would the y values be 1/2? That would be when x is pi over 6 or 11 pi over 6. Do the same thing with the other side. Sine of x plus 1 equals 0. That means sine of x would equal negative 1. On the unit circle, again, that's going to occur when x equals negative 3 pi. I'm sorry, not negative, but just 3 pi over 2. Okay, so those would be our answers. Quickly put those in red. Had to hustle through that last part there, but jot down questions that you might have. I realize I went kind of fast and maybe didn't explain things like I had hoped to, but hopefully it made sense. Ask some questions if it does not.